analyze, multivariate, discriminant, recall. Got my log variables. Now, if this says that somebody's classified as Brazil, now I'm really gonna not know what's going on. What the heck did he do? Okay. It got worse, but at least I got rid of my problem that wasn't supposed to be there. I'm not going to publish results that classify one of my points as Brazil when that's not in the data that I'm analyzing. So that can't possibly be a good idea. So what did I learn? I learned that the log didn't help me. I'm not surprised that it didn't help me because the data wasn't helped that much by the log transformation. So now I'm curious. I'm going to stick with my temporary data set. Analyze. What should I try now? Well, PLS for discrimination is something that is new. I don't know that I've ever seen it in a paper, other than papers written by me. Well, analysis done by me. Because it's not as common. But partially squares for discrimination, let's see. I bet it's going to complain. See, it won't let me. Jump says, no, I need a numeric variable right there. And my Kentucky US variable is not numeric. But I have a variable called Kentucky equals 1. Not in this data set. So I'm forced to add another column called KY. And comparison, I want to know when origin. This is how you fool software into doing what you want. Origin equals quote KY quote. Why do I know to put quotes around it? Because I've used JMP for 20 years. And it wants a quote around it. And I say, okay. And I glance down and say, okay, it looks like it's doing what it's supposed to. Anytime you create a new variable, make sure you look at it and see if it sort of makes sense. That sometimes I create variables like this and it's always 0 or always 1. Most common mistake. Or that's all missing. All of those can happen. But it looks like it's doing the right thing. I could look more carefully. And it's numeric now. It's 0 or 1. It's whether it's Kentucky or not. Analyze, multivariate. Now I want to do partially squares, but I can use my Kentucky variable in here. And I don't like my 3 log variables, so I'm not going to use those. TUV. And now it's going to make the linear combination that's most correlated with Kentucky. Should I make 3? No, I better make 2. Because I want to be able to plot it. I used to know by the way, these two ways of specifying the model, I used to know the difference between those. I don't anymore. There's a difference that PLS people can tell me what the difference is. But it's the default, so I trust my friends at JMP except when it comes to classifying things into categories that don't exist. And, oh, that's not good. It thinks that I want 0 factors. Why is it getting a weird answer? this happens in life. Oh wait, maybe I should. It's got two different scores. Here's my one weird point in the middle. Is it going to tell me how it classified? Coefficients, let's see. It definitely doesn't like the V very much. I'm not sure it's going to tell me how it classified. It's not happy with the
Is it under the Nepal split factors? Down?
ah. Let's see. Yeah, I get a lot of choices, right? See that? Okay, so the trouble is, I'm gonna have to delay on this one because I'm using it for classification, and it's not the usual way to use partial least squares. So I'll have to wait till Thursday to come back to this one, because it's not gonna. What I want to do is probably save the two PLS components and see how well it does at classifying. So we'll wait on the performance. So going back to PLS didn't help us. We're waiting, or PCA didn't help us here. LDA didn't do any better than logistic regression. So which do you publish? If you're a traditional person, you're just going to publish the logistic results because that's what people are most familiar with. I personally would add a sentence that said, well, linear discriminant analysis didn't do any better. What if I do quadratic discriminant analysis? Who said the variance in my groups are the same? Analyze multivariate discriminant, recall, and this, is it this one? Down here. This, by the way, is the one that 90% of the people forget to try, because it's not really, in most data sets, it's not a good idea. It's not really true that the covariance of the two variables are the same. So it produces, it's doing this weird plot again. So, where's my two dimensions? I mean, technically I have two dimensions here. There is a dimension here. But why the heck are they all zero? But the difference, I guess it's still a learning experience. The difference, notice the difference between the two. This one is going this way and that one's going that way. They're very different from each other. Something else is wrong in my data because the first variable is the way it is. But look, it's still getting those two guys wrong, right? These two are wrong over here. That one's wrong over there. There's probably another red one that Oh, there, you can barely see it under the V right there. But that's what, am I ever gonna classify those points correctly? Probably not. I haven't, um, I'm doing the same. So I'm not getting anywhere by the methods, which happens sometimes. The multivariate reality, ooh, I don't know what's really going on. Analyze, where can I do the multivariate? See if this works. So there's a nice summary. This is called a scatter. Anyway, it's the pairwise scatter plots. Since I only have 3 variables, I can plot them all against each other, and I have a nice summary of the data that that tells me a lot about how the variables are related to each other. Are any of them very good at discrimination? Just the individual variables, I'm not getting anywhere. So the fact that the methods are doing okay using the 3 of them together is important. At this point, I wonder if that's the one that I get. That one's weird, right?